In question 15, we are looking at calculus, and we are asked to find dy by dx, or the instantaneous rate of change for this function here. Now, before you even attempt to find the gradient, because we've got a fraction here, I would encourage you to rewrite this out using rational exponents. So I would write this in the first instance as y equals x squared plus ax to the power minus 1 minus 1. So just remember that whenever I have a fraction, if I have, well, in this instance, a over x, that is the same as a multiplied by 1 over x, and we can express 1 over x as x to the power 1. So that's a minus 1. So that's a multiplied by x to the power minus 1. So I haven't actually done any differentiation yet, so it's quite common for people to do this and then stop. All I've done there is just write it in a different form with rational exponents, which means it's easy then to differentiate. So if I want to differentiate this, it's just going to be 2x to the power 1. Now, when I differentiate this, if I bring the power down, this is going to be minus 1 times a x to the power negative 2. And then obviously, if I differentiate a constant term, I don't have a value. So I end up with this expression for dy by dx, which is what I need for part A. And then in part B, we're told the gradient of the tangent to the curve is negative 14 when x equals 1. And from that, we're expected to find the value of A. Now, the reason we can do that is because the gradient of the tangent is negative 14. So we've said that this is the instantaneous rate of change. Now, when we have a tangent to the curve, it will also have the same gradient at that point. So the gradient will be negative 14, and that is going to equal 2 times x, which we know is 1, so that's just going to be 2, minus a multiplied by 1 to the power negative 2, which is just going to give us 1. So we're going to end up with minus 14 equals 2 minus a. So therefore we can say that a is going to be equal to 16, just rearranging that.